Okay, hi, I'm Dulma. I'm from the INFER team at Meta as well. And I'm going to speak about a checker that we built on top of polls for finding retain cycles in Objective-C. So this is an example of how to build something in polls, and also how we go about building such a checker, making it production ready. So what is a retain cycle? Something happens in Objective-C, but also Swift, that two or more objects have strong references to each other, and that prevents them from being released from memory, and that can cause memory leaks. So something that causes many memory leaks in the apps, and it's easy enough for developers to do. So we are focusing only on Objective-C, because that's the front end we have. So we have a Clang front end that covers C, Objective-C, and C++, and we need to build a Swift front end to be able to handle Swift, which hopefully we can do so. Let's start with some examples of what does it look like. So this is a class view and a class delegate. The class view has a property of class delegate, and the class delegate has a property of type view. And then in the implementation of delegate, we have an initializer, and there we build a new view and then assign self.view.delegate equals self. So then at this point, that's a retain cycle, because they are both pointing at each other. And the pointers are strong, so they're retaining each other. So the solution to not have a retain cycle in this case is to write one of the properties to be weak, which means you still have the pointer to that object, but you are not retaining it. So it won't be increasing the retain count on the object. And so this is kind of a common pattern. That's kind of what the developers should do in that case to avoid the retain cycles. Another common pattern is to do with Objective-C blocks, which are the closures. So here we have a class user that has a property callback, that's the block, and a property name. And then in the initializer of user, we have that self, we assign callback to self, which is the block. And inside the block, we use self. So using self in a block means capturing it, and that means retaining it. So that also means self is retained in the block, and block is retaining self, so that's also a retain cycle. In this case, the solution that is recommended is to use a weak pointer to self, and then capture that one, and then inside the block, kind of making the weak pointer strong again to make sure it's still there, and then if it's there, use it. So that kind of the pattern that the developers use to avoid these kind of retain cycles. So yeah, we want to build a checker for this in polls. So thankfully we just had Jules talk, so you know more or less how polls works. So we basically use the abstract heap of polls and the abstract interpretation that polls provides, and we try to find cycles in this abstract heap. And so we just need to check that there are cycles and that the references are strong between the objects. And then in that case we report. So we need two parts to report. We need that there is a cycle, and we need that the references are strong. So yeah, then I'm going to go through different aspects of the implementation. So one aspect is where do we check, where do we report? And so for making it more in sync with the definition, we should report at the place where the variables are going out of scope, because then that cycle won't be able to be broken later. But we tried that implementation in the past, and it led to not reporting very much, because So basically, we just learned that Pulse gets rid of some disjoints on the way. So that leads to not complete code coverage. So we have the problem, so we just need to make sure that we report as soon as we find a cycle to maximize the ones that we report. So that's what we're doing. The option 2, and that means we have more reports, but we can have some false positives because it could be that the cycle is created but later broken. And in that case, then we'll report anyway. But in practice, hasn't been a problem. Okay, so let's look at error messages. So this is an example again, the first example about the class view and the class delegate and the objects returning each other. Question?
Sorry, I had a question on the previous slide. Yeah, why do you get more false positives if you report the cycles as soon as they're created? Is that because they might then get, the cycle might get removed later on?
That's right there. So
Okay.
maybe they just create the cycle temporarily and then assign one of the variables to nil afterwards, and then that breaks the cycle.
Okay, thank you.
So we have this example, so let's look at the error message here. So we say retain cycle found on line 22 between the following objects: self a review assigned on line 21 and self a review the delegate assigned on line 22. And so we use an internal decompiler to give meaningful name to both abstract values. So that's how we get those names. And then in this example about blocks, so we say the same, but we say self arrow callback is one of the objects assigned on line 13, and then in the other one we say self was captured by this block defined here. So we can give this information about where the objects involved in the cycle. And so one thing that can be improved later is that we say precisely where the variable is captured. At the moment we say it's captured by the block, but it could be more meaningful if we say it's captured here line 14, because they see, otherwise they need to look through the whole block to see where self is actually used. But something to improve for later. So let's look at how this, yes.
Could you just remind us what is a block in Objective-C, how it works?
I mean, it is a closure, just like lambdas in C++, etc.
Okay.
So let's look at how this looks inside Pulse. So again, let's look at this example, and we'll look at the implementation of this bit, the execution of that bit, where we want to assign self to the delegate. So first we get the view. So this is SIL code. First we get the view, then we assign the delegate to that view. And so at the end of this execution, a simplified heap of Pulse looks like this. So we have the roots and 2 and 3 and 4 and self. And then we have the memory that looks like this. V1 points to V2, V2 points to V6 via view. Then V6 points to V5, V5 points to V12 via delegate, and V12 points to V2 again. So that's the cycle. And an important thing is that these accesses need to be strong. So we check all that. And also, we have information about which class it is in the attributes. So that's where we store the types. Yes.
You mentioned that these two references have to be strong. What about the cycle is longer than just these two? What happens with the rest?
Yeah, I guess everything needs to be strong, but generally, yeah, the pointers need to be strong as well. Yeah, we check that too. Right. so the class. So we also want to only report on Objective-C classes, so we check that the values in the cycle are either pointers or Objective-C classes. Yes, please.
Yeah, sorry. When you say pulse state, does that mean that this information is already tracked by pulse by default, or you kind of plug in to pulse with extra information that you want tracked in its memory analysis, like whether pointers are strong or weak or that kind of thing?
So I will get to that later, what we do about the pointers being strong or weak. That was something we had to fix towards the end. But other than that, everything was already in pulse. And I will also mention later an attribute that I added just to avoid duplicates. So yeah, we can add attributes, we can change pulse, whatever we need. Right. So for closures, we did have to do a lot of work in pulse to implement the closures in a way that let us execute them properly and also find the retain cycle with them. So we interpret them as objects, and so basically when we have a closure, we say this is an object of type the name, the internal name that we give to the closure, that's the kind of type name. And then the variables become, the captured variables become fields of that object. I'll show an example in a minute. Yeah, that helps with this check because it's then trivial to find cycles between blocks and their captured variables because it's all the same objects and fields. So that was the example we had. So in this line, when we assign the callback to self, this is what happens. So we have set callback, and there we have, this is the SIL again. So this is the closure object, and this is telling us this is the closure we're talking about, and these are the captured variables. So self is captured. And so after we execute this in pulse, we again get this heap. So we have that the type is the type of the block. We have the root itself, and then again we see V1 points to V2, V2 points to V6 via the callback, V6 points to V4, V4 points to V5 via this self-captured by value. So that's the field of the closure. And then B5 points to V2 again. So that's basically the block pointing to the captured variable. And that's, again, another cycle that we can find in the same way. And we take into account also the types so that we have this, one of them is an Objective-C class and the other one is an Objective-C block. So these are the only ones we want to track. Okay, so let's talk about a few more improvements to the implementation. So one is about duplicates. So one issue with reporting right when the cycle is created is that we want to continue the execution after that, and then you will just keep seeing that cycle later more and more times. So one solution I found for this is to add an attribute. So every abstract value that is involved in a cycle after it's reported gets this attribute in reported retain cycle. And then when we see the attribute, then we don't report again. So it's quite a clean way of avoiding duplicates. And then, yeah, then this is the bit that is less fun but very important. So all the implementation is run and the test pass with our small examples, but that doesn't mean we can ship it. It means we need to then start looking at clear code. So we look at how the checker works in clear code, and if it has false positives. And then we iterate from there. Look at the false positives and try to find what are the problems, what needs to be improved, and fix them. And when we see a good, I mean, we won't aim for 0 false positives, but we aim for a good checker that doesn't have too many false positives before we release it to the users. So, and then finding false negatives is harder because obviously we don't know where they are. So for that, we generally work together with developers that know what are the in this case, retained cycles that happen. And then they give us the examples. We try to run the checker on these examples to see if the checker can find them, and if not, why, and improve from there. So we need to do all this work and iterate on that. And so I won't go into details of the false positives we found, but just to give an example of what kind of issues. So we found front-end bugs, or missing front-end feature, or an incorrect model. We were also reporting issues when polls saw that the objects were nil. That also leads to false positives. So we fixed all that. But I mean, in this example where I looked at all the reports for this particular checker, it was never polls' fault. So we had a question about the false positives of polls in the previous talk. And so it's an example of like polls generally is pretty accurate in its own execution. That it was never like polls was completely wrong in the execution. So for false negatives, so we had this basically implementation problem of where we find is this field access weak was in the type environment. And so the Clang frontend produces a type environment for each file. So there are different type environments. And sometimes the type environment that we have at hand when we're checking the retain cycle was not the correct one. And so we were missing this information about whether this field is weak or strong. In that case, we were assuming that it's not weak, so that we don't report false positives. But we were missing many reports. And then, yeah, the solution we found was to just, because this is just a Boolean, we just store it together with a field name in the SIL instruction, and then that gets passed to the pulse heap. So it's kind of in the right place. We don't need to find any type environments. And the number of issues we were finding increased over 100% after this. So it's an example of kind of thinking outside the box. Like you get fixed in one implementation way of doing things, and then try to think differently. Yeah, the other false negatives are just because of polls. So it will get rid of many disjuncts. It will miss many code paths. So there are many issues that we won't find because of that. And there's just improvements we want to do to polls to try to cover more code. So that's basically the future work on this checker will be that. So try to look at ways of finding more issues and then improving the error message with more accurate information about the captured variables. And that's all I have. Thank you. More questions?
I can ask the first. Yeah, about the type environment, you mentioned that with the Clang frontend, we have several type environments. So what is the story behind that? Could we merge all this information into a same type environment? Because I know that other frontends have another point of view.
Yeah, so in the front-end part, that's all done in parallel. So each file gets translated individually, so the type environment gets added like that. And then we could have an extra step in between front-end and back-end where we merge it. We've never done it. We've thought about it. Don't know if Nikos has any ideas.
I think that in Clang the problem is that the same type name can have completely different definitions in different source files, right? You can, depending on what you include, your types will have different definitions. So you can't just merge. It is a very local view of the type environment that you have in C++, right, or Objective-C. So I don't see how you could merge. Yeah. And actually, yeah. Does that make sense?
Yeah.
Yeah. Actually, I wanted to ask a question as well. The examples you showed have cycles of size 2, but in the pulse heap, it's not actually 2, it's longer. Does this mean that you automatically get reports for longer, for cycles of longer visible length than 2?
So the examples I showed have 4 elements, but one of them is the pointer, the other one is the object. So it's a pointer to the object. So it's no point showing 4 things to the user. So basically internally then I just remove the 2 of them that are not the pointer and just leave the 2 that are the pointer, and then those we use to the compiler to find a meaningful name for those, and then that's what we show. So yeah.
But would this already work if you had 3 objects in the cycle?
Yeah, it works if you have any size. I mean, in practice, we haven't found that many cycles that are like many objects, just because of that would be just a lot of execution that pods need to get right to get that cycles.
So in case we get a Swift front-end one day, is it still a property that makes sense for the Swift language?
Yes.
Do you think in general that the current properties that are checked for Objective-C could be still of interest for Swift?
Yes. So in the case of retained cycles, that is the case. They still have them in Swift, and they're interested in getting that checked. And so we will need to see case by case, because obviously the languages are different. So I think nil problems are less of a problem. So yeah, some checkers would be useful, some less useful. We need to see what are the problems they have and build new checkers as well.
Okay, not more. Yes.
Thank you for the talk. I wonder this cycle between variables, could it be used for other properties and like reference counting, loops, like for example detecting circular lists or things like that, where you could try to find cases where you're not intending to have circular data structure but you do, or things like that?
Yeah, absolutely, it's the same.
Have you tried this analysis on like something else than Objective-C, for example C or C++?
I mean, I saw examples of reports that were including C slots as well. I just tried to remove them just to avoid false positives, because what we care about is in Objective-C. But even without client, there were C objects involved, so that it's just checking cycles in the heap. You can check for any cycles with similar kind of ways.
Yeah, I think in C++ with shared pointers and other ref counted things like this, you could check a similar property and get useful bug reports of unintentional retained cycles there as well. Yeah. So that could be cool.
So.
Yeah, I was curious. So in practice, when the kind of bugs you have found, what was the size of the cycles? How many interprocedural calls did you follow to catch them? Do you have some numbers about that?
I mean, just from what I've seen, so I haven't seen, I think, many that are more than 2 objects. It's a very common pattern, the self and block. And also the delegate being weak, so kind of 2 objects returning each other. But the examples that I know exist have 4 or 5 objects, so we're just not getting there yet. And in terms of interprocedural calls, yeah, there are a few interprocedural calls. Also, a specialization of blocks. We need to be able to see what's happening with the block exactly, calling the block and going back.
And how do developers react when they see this tool working?
I think they like it. So every time they have seen them in diffs, or I have mentioned it to them that cycle is there, they want to fix it. We made a post to them. There were a lot of comments about how good is this. So it is a problem that causes them a lot of hours to actually fix or find. So we're not finding all of them, but the ones we find is easy for them to fix because it's a diff time. So it's when they submit the code. So it's better than later they get a task or you're crashing the app with this retain cycle, fix it.
Yes, because for them, what is the symptom of the problem? It's just a memory leak, and they don't know where to start to look at. I mean,
yeah, that could be an issue. But there is also a dynamic retain cycle checker that creates tasks for them. So that the tool finds the issues and sends them the task, and then, well, they need to see how to break the cycle and how to check that the cycle is not there anymore. So a bit harder maybe than, because also a context switch than when they're just developing the code. If they see the cycle right there, and it's easier.
And do you think this kind of analysis could also work at IDE time?
Yes. So at the moment, it would need to be fast enough running the analysis with all the dependencies needed to be fast enough for the IDE. But I think, yeah, if we make it a bit faster, that would be fine.
Okay, no more questions. I think we will stop there. Thank you very much.
Thank you.